All right, welcome to This Explainer. Today, we are diving deep into the ultimate cosmic origin story. So get ready because we're about to completely shatter almost everything you thought you knew about the universe, time, and the very fabric of reality itself. Think of it kind of like unmasking the greatest superheroes and villains of physics to finally reveal their true identities.
We're going to start things off with a massive revelation from the renowned physicist Leonard Susskind. He's basically dropping an absolute bombshell on a fundamental truth that, well, virtually every single one of us was taught in high school physics. He's talking about a phrase that our entire civilization uses to communicate science, and yet he calls it wildly misleading. So what phrase is he talking about? The speed of light.
Yeah, you heard that right. Like a bold, colorful splash page straight out of a comic book. You really gotta let this sink in. C is not a speed. The so-called ultimate speed limit of the universe is a total illusion. It's not a speed in the way a fast car or a pitched baseball has a speed. Honestly, calling C a speed is like calling gravity a push. It entirely misses the point of how our universe is actually constructed.
Section 1. The Great Cosmic Illusion. Unmasking the truth. So if it isn't a speed limit, what exactly is it? Let's pull back the curtain and look at what Albert Einstein actually uncovered about this four-dimensional reality we live in. Okay, let's dive into this. Space and time, they are not two separate stages where the events of the universe just happen to play out. No, they're two sides of the exact same coin, a single, unified fabric we call space-time, and C simply acts as the currency exchange rate between them. Think of it like traveling internationally. You need to know how many euros equal $1, right? Well, C tells the universe exactly how much space equals how much time. Basically, 1 second of time equals roughly 300,000 kilometers of space. That big 300,000 kilometers per second number we all painstakingly memorized, it's just a human artifact. It's totally based on how we arbitrarily chose to measure things. If you measure distance in light years and time in years, that massive, intimidating number vanishes entirely. And what are you left with? Just the pure, unit-free number, 1.
Which brings us to Section 2, the unification constant, binding reality. Because here is where we find the true superhero identity of C.
Rather than a speed limit enforced by the cosmic physics police, C is simply the geometric signature of the universe. It dictates the exact structural ratio of how space converts into time and how mass converts into energy. It is quite literally the shape of everything, the fundamental blueprint that allows our universe to even exist in the first place.
Now, how does your personal interaction with this geometry actually work? Well, every object gets a fixed superpower budget of C for moving through space-time, and you are always spending this budget. Right now, while you're sitting still, you're spending all your motion budget moving through time. But as you speed up and move through space, you have to rob from your movement through time to pay for it. The faster you move through space, the slower you move through time. It's a strict geometric trade-off.
Let's move on to Section 3. The speedster's curse, the life of a photon. Let's take a look at the ultimate massless speedster of our cosmic comic strip.
Because light has absolutely zero mass, it has zero resistance. It gets pushed all the way to the absolute maximum space speed. It spends its entire geometric budget just moving through space. And because that budget is strictly capped at C, there is exactly zero budget left over for moving through time, meaning literally zero time passes for a photon. From the perspective of light itself, it doesn't age at all. It crosses the entire universe in what feels like an instantaneous zero. Crazy, right?
Armed with this mind-bending, super flexible understanding of how local geometry actually dictates time, we're facing a massive, real-world cliffhanger out in the vastness of the cosmos. If time is a strictly local experience, dictated by movement and gravity, well, have we been measuring the age of the universe all wrong? This brings us to a currently breaking mystery. Section 4, the early galaxy puzzle, a cosmic mystery. Because the James Webb Space Telescope recently peered into the deep, dark past and spotted an anomaly that threatens to completely rewrite our cosmic timeline. The telescope looked back to just 500 million years after the Big Bang. Now, according to our standard cosmological clocks, the universe was basically just a cosmic infant back then. We should only be seeing chaotic baby galaxies. But JWST found fully formed, incredibly mature galaxies. This is absolutely baffling astronomers who rely on standard universal cosmic time. Honestly, it's like finding a fully grown adult sitting in a kindergarten classroom.
To solve this incredible mystery, we enter Section 5, Gravity's Local Time, Warping Spacetime. We have to bring in the heavy hitter of our universe, gravity. Because gravity doesn't just pull things together, it actively warps the very fabric of the spacetime we've been talking about.
So the absolutely crucial point here is this concept of proper time. Time is not an absolute universal clock ticking away in the background for everyone. It's experienced locally. Actually, we know this for a fact. GPS satellites have to correct their clocks every single day because time runs differently in orbit than it does down here on Earth due to gravity. Near a black hole, time slows to an absolute crawl. Proper time is essentially your own personal wristwatch, and its ticking is entirely dictated by the gravity you're experiencing. When we think about the timeline of the early universe, it builds a brilliant new hypothesis. The early universe wasn't just less massive, it was packed with immense energy, radiation, and wildly varying gravitational landscapes. So while standard cosmology says a distant galaxy is globally 500 million years old, that specific localized pocket of space may have pushed all the way to 1 billion years on its own, local watch. If time is fiercely local, this solves our mystery so elegantly. These ancient-looking galaxies didn't form impossibly fast. No, they simply experienced far more proper time than the space around them. Because their intense local gravity caused their clocks to accumulate way more time. Stars had longer to form, black holes had longer to grow, and the galaxies themselves had longer to evolve. They got a massive cosmic head start, all while the global timeline of the universe remains completely unbroken. But of course, there's a catch. While this localized time warp perfectly explains the galaxy puzzle without requiring any exotic, made-up new physics, it still faces a formidable villain: the cosmic microwave background. You see, the background radiation of the universe is astonishingly uniform. Any theory proposing wildly different local time zones has to explain how the background of the universe still looks so perfectly smooth to us today. It's a massive, high-stakes scientific bar to clear. Tying this grand cosmic mystery all the way back to our original revelation, we reach Section 6, the shape of reality, geometric rules. We're seeing that from the tiniest photon to the most massive galaxy, the universe is governed by uncompromising geometric rules. This is exactly why you can't just slap a bigger engine on a spaceship to go faster than light. You can't exceed c because there simply is no slot in the geometry of spacetime for it to happen. It's not a speed limit you can break. It is a geometric impossibility. It's literally like asking someone to draw a square circle. It completely proves that c isn't about speed at all. It is the literal shape of reality itself. So as we sit here, continuously spending our geometric budget, moving through time at the speed of c, we really have to wonder, is our universal clock far more complex than we ever imagined? Perhaps the next great breakthrough in understanding our origins won't come from finding exotic new particles, but from finally grasping the superhero-level flexibility of time itself. The universe is speaking to us through geometry. Are we finally ready to listen?